has actually been one of the flagship workshop programs for the Process Improvement Special Interest Group. We've been conducting and offering Six Sigma Yellow Belt certification training for, I guess, about 6 years now. We've had over 350 students that have taken the class and received their certification. We're very proud of this program, and I think hopefully you will get a lot out of it. For the course, this course will enable you to get your Six Sigma Yellow Belt certification. The requirements are that you attend the training and complete all the webinars. There will be a certification exam that will give you at the end of the course, and you need to get a passing score of 70%. There's going to be 30 questions, so you have to get at least 21 correct to pass the exam. And you will be required to submit a feedback survey on this course as part of the requirements for certification, because it's important for us to be able to get feedback so that we can continue to make improvements in the course as needed. And also, we're also very interested in understanding what it is that you liked about the course, what worked well, what can be done better, and those kind of things. To introduce myself, I'm Perry Walker. I am currently the owner of my own little consulting firm, but I received a chemical engineering degree from Caltech and a master's degree from Georgia Tech. Had a series of very successful careers. Worked for DuPont for over 20-something years. Basically moved up the corporate ladder until the business that I was a part of was sold. Went into consulting, was in pharmaceutical consulting for about 7 or 8 years. Most recently, I was the global director of Lean Six Sigma for Continental Tire and Rubber Company. More importantly, I've been a member of NSBE for over 40 years. I'm currently on the National Advisory Board for NSBE, and been the technical advisor for the NSBE Process Improvement SIG for the past several years. I'll let Antonia introduce herself. She's going to be the co-instructor for the course and to help facilitate the course. So I'll let you introduce yourself, Antonia.
All right. Thank you, Perry. It's okay to call me Toni or Dr. Toni. I work in industry for John Deere, been there 25 years plus. Background has primarily been in manufacturing operations, product support. Been a senior quality engineer most recently. Currently, I'm a project manager in a hybrid type of role with HR, but I'm still utilizing the tool set that I learned when I was a green belt. I took white belt, yellow belt, green belt, and have an ASQ black belt. And I actually will be recertifying at the end of this year, probably for like maybe the 4th time. And Bachelor's of Science in Mechanical Engineering, North Carolina State University, part of the local NSBE chapter in the Research Triangle area, lifetime member of NSBE, and been a part of the Process Improvement SIG probably for about 3 years. I say it's the best special interest group. If you're a professional member and you're not a part of a SIG, you're missing out. I like this SIG because it's what helps keep our skill sets fresh. And if you're a college student and you're taking this class, you're getting ahead of the curve. So you want to make sure you're learning how to apply the tools. I know a lot of people really get excited about getting certified. Certification is good, but application is even better. So like it may take you a while to really understand the tools even after you get certified. So, don't be as quick to run to the next certification. Make sure you had some time to practice the tools. So that's just my advice. Also want to just mention too, some people did not register for day 2 or 3. So you actually need to sign up for all 3 days so that you can get attendance for each day. I know that the 2nd day and the 3rd day had less attendance registered. So I'll look at the roll today, and if I don't see that you're registered for all 3, I'll try to nudge you. But please, I sent an email out yesterday with that information. If you have not done that, please try to do that before the end of the class today.
Okay. Now, we're not going to go do the exercise and go around the room and ask, why are you here, or what do you hope to get out of this class? I'll just say that by being here and choosing to be part of this workshop and part of this training, I'll say you made a good choice. And I'll go back and kind of reflect a little bit back on my career to kind of give an example of the value of being certified in Six Sigma. As I mentioned, I had a very successful career with DuPont. Actually started working for them literally right out of high school as a summer intern, and had a great career progressing through the company, eventually became a plant manager. And that was a time when DuPont embarked on fully engaging in Six Sigma as a way of improving their operations and a way of doing business. While I was with DuPont, I went through and received my Six Sigma Green Belt certification. And a little bit later on, as we give the introduction to Six Sigma, we'll explain what the different belt levels mean. So yellow belt is kind of like the starting point. Then you can go up to green belt, black belt, master black belt. Well, I became a green belt when I was a plant manager. I moved into a corporate headquarters role and became a Six Sigma black belt, eventually became a master black belt. And then DuPont sold their fibers business, which I was a part of. I didn't really like the new company that had bought the business, so I left and went exploring new career opportunities. And I actually was able to I was recruited to work as a consultant for a top-notch life sciences and pharmaceutical consulting firm. Now, I'd never actually been in a pharmaceutical plant before, but having that Six Sigma certification brought a lot of value to that industry. So the plug for you getting Six Sigma certification is, besides the fact that it will help you improve the way in which you do the work in your current roles, it also gives you a skill base that is very transferable and very applicable to pretty much any process. So it actually has enabled me to go from working in the DuPont type businesses, which is like fibers or plastics or those kind of things, to working in pharmaceuticals. I've worked in healthcare. I've worked in transactional environments. So I've been able to make seamless transitions from one industry to another because I've got the skills in this methodology, this problem-solving, process improvement methodology that can be applied to just about any process. So I'll say you made a wise choice by starting this journey and learning about and getting certified in Lean Six Sigma, like Antonia or like Toni mentioned. You'll learn you'll get introduced to some valuable tools today. If you continue the journey along Six Sigma, you will develop some skills which will really help you in the work that you're doing, and hopefully you'll find ways to apply it. But like I said, it's a valuable certification to have. What we're going to cover in these sessions, and like I said, we have the first session this evening. We will have another session on Wednesday evening, and then we'll spend 4 hours on Saturday to complete the course. The topics we're going to cover, we'll start out tonight with an introduction to Lean Six Sigma. So one of the things you'll be able to do after you leave today is, most of you have probably heard of Lean and Six Sigma, but you'll be able to give a coherent definition. If somebody asks you what is Lean and what is Six Sigma and what's the difference, you'll be able to give a concise answer as to what those things are. So you'll learn what is Lean, what is Six Sigma, what is the difference, what's the synergy. We will then go through the Six Sigma process, and the Six Sigma methodology follows essentially a 5-phase process. Tonight we will cover the define phase, and there are several deliverables in the define phase, including what's the voice of the customer, a project charter, and how to do a high-level process map, and what is your project why, and I'll define later on what that is. On Wednesday, we'll come back and go through the measure phase. And that's where we get into a lot of the nuts and bolts of what Six Sigma is all about. And that's using data to make decisions. So we'll learn some basic statistics, the operational definition of a metric. We'll talk about measurement system analysis and process capability. Then we will wrap things up on Saturday, go through highlight the analyze phase, where we'll talk about using technical graph, doing process analysis, and a variety of tools in the process analysis toolkit, culminating with hypothesis testing. Then we will go into the improve phase, and I'll give a brief introduction to design of experiments, and then the control phase. And then we'll give an introduction to control charts, and then we'll summarize and wrap things up. So that's kind of the order of topics that we'll cover. Like I said, tonight we're going to go through the introduction to Lean Six Sigma and the define phase. So I'll turn it over to Toni and let her go through the introduction of what is Lean and describe to you what Lean is and what are the key elements of it.
All right, thank you, Perry. And also, too, I'm going to ask you to put some stuff in the chat because I actually like to read the chat, and that allows me to collect some qualitative information. So if you haven't already done so, you want to put something in there while you're taking this class, please take maybe, about 10 seconds and drop your why in the chat in one or two sentences as we go through this. So what is Lean? We can go ahead to the next slide. Some people may have heard of just Six Sigma and Lean Six Sigma. So Lean is really focusing on the reduction and elimination of waste. Waste costs money. When you go to order something from your favorite restaurant, Chick-fil-A is one of my favorite examples to use. I want to get it quickly. I don't want to have a whole lot of unnecessary waiting and extra motion, those kind of things. The customer doesn't want to pay for them. And we'll talk to that. But here's what's called the 8 types of waste. So take a look at this. Transportation, meaning you're moving items or information unnecessarily, like unnecessary walking. Inventory, having too much inventory, items of information that customer has not received. Motion, excessive movement within your workspace. Waiting for information or items to arrive. Over processing, doing more work than was absolutely necessary, or overproduction, meaning that someone is building up a whole lot of stuff that's not really helpful for the final outcome. Defects. I really have a pet peeve about defects. It kind of gets on my nerves to see defects unfolding and, not being able to do anything about it. And skills, not using workers to the fullest of their abilities. So these are considered waste. And then when we talk about Lean, we want to reduce or eliminate waste. All right, we're going to break down each one of them, and thank you for you all dropping your reasons and your why for taking this class in the chat. All right, 8 waste. First waste, transportation. When there's a poor layout, that exasperates the transportation, meaning that you're having to do a whole lot of extra movement that's not necessary. Transporting waste in material movement. So sometimes in a factory, if in a certain setting, a forklift driver has to replenish the assembly line, but they have to drive pretty far to get something that's needed very often. As an example, when you walk into your house, you want to put your coat somewhere that's right by the door. Like you don't want your coat to be, upstairs every time you need to go get it. You want it to be nearby. When you get your car keys, you usually put them somewhere near the door, right? You don't put them, very far from where you need them. So transportation and poor layouts are examples of that. You can go ahead to the next one. So that's the first one. The second one is having inventory issues associated with excess inventory. Sometimes just having too much inventory makes it hard for you to find things that you're looking for. All right. Next one, ties up capital. Yeah, you may get a good deal on something, but do you need to pay for it and pay to store it? So I know, think about that. Like a lot of people maybe did that on Black Friday. They went out and bought a bunch of inventory or something that they're not going to need right away. So you have your money tied up in inventory. All right, the next one. Motion. What are reasons why there is wasteful motion? So can you think of something that just might be, as an example, motions that are in excess or not necessary? If you are sitting at your desk and you have things that you need right beside you, as I'm having this meeting, I have my coffee right here so I can easily get it. I wouldn't want it across the room, so I have to go very far every time I need to sip it. But those are just some examples. But motion itself can be wasteful if you just have things not in the right place. If you need to reach something very often, you want that to be easily accessible. All right. The next one. Go ahead.
One of the examples I always like to give to define a lot of the lean concepts is how you work in your kitchen. And you know, for instance, where do you store your utensils for stirring pots and things like that? Where are the spatulas and stuff? Are they typically they're in the drawer next to the stove, in contrast to the drawers on the other side of the kitchen? Because like Toni was describing, if you have to move around to get something, that's excess motion, which is wasteful.
Yeah. And think about the way you lay out your refrigerator, like the drinks that you like the most, you probably got those like easily accessible versus, far behind things. All right, waiting. This is the fourth waste. What are examples of waiting time? Frequent interruption of manufacturing equipment or processes, waiting for the next production step, waiting for quality checks. And sometimes if it's a transactional environment where you're not actually putting your hands on something, maybe in your current job, there's something that you can't do because someone has to process something or do something to it before you get it. Or as a student, if you're working on a project, you've done your part or you're waiting on someone to do their part so you can do your part. So waiting is a waste, especially if it's excessive and it's not conducive to the overall process. And waiting also costs money. When you get in the real world, waiting in any kind of waste costs money. So you want to eliminate that as much as possible. And I had to go to the doctor today and I had to wait for like 30 minutes, and the doctor was like, I am so sorry. I am so sorry. I'm like, I am too. All right. So overproduction, producing more than the customer needs. It's not necessary. Does anybody love Dollar Tree? Like, just show your hand if you like, or shake your head. Dollar Tree is all overproduction stuff, or it's defective. That's why it's at the Dollar Tree. So anytime you produce more than what's necessary, overproduction costs money. Thanksgiving, if somebody made too much food, they probably made everybody take a plate home or something like that. You didn't really want it, but you took it anyway. Costs money. All right, the next one, number 6, over processing. Requires additional tooling as a result of the selection of the wrong process, inefficient use of equipment, maybe poor 5S implementation, and we'll talk about the 5S's as well. But just having to do too much processing to get the outcome that you want because of inefficiencies. All right, and here's the one that I don't like the most is defects. What are the costs of quality associated with defects? Additional materials. Defects come from things that are, there's a process check that was missing, or there was a quality issue with the outcome of something, and because it's a defective, we might not be able to use it, or perhaps the customer's expectations are not going to be met. And if you can't use it, that costs money to the company every time they have to scrap or rework something. And it doesn't make the customer happy either. All right, number 8. Number 8 is one that has been added over the years. Skills, unused skills. If you have people who are working in places where they're underutilized, that's called skill underutilization. For example, what are management issues that result in skills being underutilized? Poor communication, failure to involve people in workplace design and development, lack of inappropriate policies, incomplete measures, poor management, and lack of team training. So when people's skill sets cannot be maximized, that's actually wasteful.
Yeah, and like Toni mentioned, the skills unused is something that has been added in recent years. It used to be that the acronym by which you could remember the 8 wastes was Tim Wood, but now it's Tim Woods. So this, this gives you a quick overview of the T is for transportation, I is for inventory, M is for motion. The 2 O's are for overproduction and overprocessing. The D is for defects, and the S is for skills underutilized. So that's an easy way to remember the 8 wastes that we're trying to eliminate with lean.
Awesome. All right, and I see people have dropped in the chat. And then if you want to also add in the chat some waste that you have experienced today from those 8. If you experience waiting, over processing, motion, transportation, if you experience at least one of those already today, feel free to drop that in the chat and just tell us, yes, I experienced this and what it was. All right. All right, let's talk about customers and value. The customer is only willing to pay for value. Okay. Value adding means performing work that the customer is willing to pay for. So as an example, I'm willing to land safely. Okay. If I got to pay extra money for a good plane ticket, on an airline that's going to get me where I need to go, get me back safely, I'm willing to pay for that. I'm not willing to pay $20 for a hamburger. Okay. It might be the best one I've ever had, but I don't know that I would buy that too often. Waste means adding cost, but not adding value. So if someone has to pay a whole lot more for something, but it doesn't really add value, then they just kind of feel like they've been gypped. You get a hairstyle that costs you like, a whole several $100s and it took you 8 hours to get it done. You might not be that happy about it. Value added activities. So there's a difference between value added and non-value added. So value added means activities which transform a raw materials or information into products or services which the customer is willing to pay for. I'm willing to pay for things that affect my health, things that affect my safety. I'm willing to pay for a reasonably priced oil change, or something that I purchase, a cell phone. I'm willing to. Sometimes they're a little costly, but I'll get one that is I try to tend to stuff that's people don't want anymore, but it's not it's still useful. Non-value added is activities which consume time, space, or resources, but they don't actually add value to the product. So as an example, if you had to pay extra because a process was inefficient, and that inefficiency was causing the product to pass that cost on to you, you may not want to pay for that. You want to pay for the minimum of what's needed to make that product, and then maybe what it costs to pay people to make it, and also doing it optimally and efficiently. Some examples of value-added activities: taking the order for a rubber hose, manufacturing the rubber hose, adding strength to the hose with wire, or delivering the rubber hose to our customer on time. That's just a manufacturing example. A non-value-added activity: storing the rubber hose in a warehouse. That has to be stored, so there's an overhead that gets passed on to the customer. Moving rubber hose from one storage location to another. Perhaps that has to be done by forklift. Searching for rolls of rubber hose in our inventory system. Information handoffs between various computers tracking the systems, and testing and inspection of the rubber hose. So those are what we call non-value added, because they're not actually helping us produce the rubber hose, but we have to pay for them in order for the hose to get to the customer. Same thing with your vehicle. I like having a vehicle that has seats and windows and all of that. I had to pay for those things, but I also had to pay for the forklift driver that had to transport the tires over to that station. The quality check, those are not necessarily considered value add because they didn't add anything additional to the vehicle, but that cost is passed on to the customer.
So good. So basically, to summarize the concept of lean, it is about the reduction and eliminating of waste. And if anybody ever asks you, well, what's the definition of lean? The answer is the reduction and elimination of waste. And we identified a number of activities or things that happen that are considered as waste. Now, we added in this section of value added versus non-value adding activities because a lot of these things are important in terms of for a manufacturing operation to be able to make something and deliver something. A lot of these things, activities like, for instance, putting it into storage or checking it for quality, are activities that the company has to pay for. But the point here is that the customer doesn't pay extra or doesn't want to pay extra for the fact that you have to now inspect your product. They expect the product to be right. The customer is willing to pay for the stuff that goes into making the product. So the challenge is for us to figure out how to eliminate as much of the and as many of the non-value added activities,
and I've fed her since 5:30.
so that
Huh?
you're only
5:30.
adding costs. Somebody needs to go on mute. So that you're only
got it.
adding costs that a customer is willing to pay for. Questions about lean before we go into a quick introduction of what is Six Sigma.
And just to kind of let you know, looking at the chat, Perry, quite a few people have added to the chat why they're in this class, what they're looking to get out of it. Some have some familiarity with it. Some just coming to expand their knowledge, building a resume. All good information. And any questions on lean? Anybody having an example they want to share about those 8 wastes that they may have experienced yet today? Couple of hands up. Go ahead, Alina.
So I read that for some milk companies, like all of their milk is organic, but they advertise both organic and regular milk. And I wanted to know if that's an attempt at like reducing over processing or if that's just wrong. I don't know.
I think there, in this case, company offer a variety of products that to target certain consumers. In this case, they're offering, you know, both an organic and a non-organic product. The organic product, it involves more cost for the manufacturer. However, there are customers that consider the fact that all the ingredients are organic, they consider that as value adding. So from a customer standpoint, that may be a requirement. So therefore, the producer will deliver both a product that meets the higher level of standards, or that is more of a commodity. So this is so in this sense, both products are value adding to the business. They're just targeting different customers.
And can I just add something onto that, Perry? Depending on how the process is, sometimes in a manufacturing facility, the same products might be made on the same assembly line with different configurations or some slight adjustments. And depending on what it costs them to run those, sometimes they batch build, sometimes they mix model. Depending on how they do it, it may be in their best interest to produce them at the same time versus batch build. So it's a lot we could probably dive into to understand it a little better. But thank you for your question. I see we have a question from, is it Kayla? Holly?
Yeah, it's Kyla.
Kyla, sorry, Kyla.
No, you're fine. I don't have much of a voice right now, but I'm like coming from a different approach, so like not manufacturing or necessarily engineering background, but for what I'm taking this for is more so for like understanding and planning processes. Because I'm like developing an educational program, but I feel like there's still benefit to this. As far as like you were just saying value added versus non-value added and like how that changes for different, I guess, stakeholders or whatnot. Is it I'm almost thinking of like a logic model type of thing. Is it beneficial to make multiple, or like are you viewing this from, is our goal to view this from our standpoint?
It's always from the voice of the customer. The business is a stakeholder as well, but it depends on what the customer is willing to pay for. Me personally, I'm willing to pay extra for organic. I will go to Whole Foods. I'll pay a little extra for it, right? But it's on some stuff. Now, some stuff I might not, but it depends. So it depends on the customer and why they need it. So yeah, we can, if you want to talk offline about that, we can, but thank you for your question. Also, I was gonna say this real quick. You don't have to be an engineer to be in this class. You don't have to be in anything technical. You can use Lean and Six Sigma across, all disciplines. I'm actually using it for music ministry. Like I have a whole book on how I use it for that.
Yeah, I think, let me just make a couple of comments here. I think the concept of, we're using the term value, like value adding versus non-value adding. I think it's important to not try to get into what's of value to one person versus another person. We can keep this very simple. Is it an activity that somebody's willing to pay for? And I'll give you an example from a non-engineering standpoint. I work with Independence Blue Cross on helping to streamline some of their processes on how to handle claims and things like that. And what I discovered in their processes, they will do stuff like they'll take in some information, they will enter it into the computer, they will print it out, they will then take that printout and file it someplace, they will issue a check, or they'll cut a check. The check will go to 2 or 3 people for authorization. They'll make a copy of the check. They'll file that copy. So all of these things are steps in the process that cost Blue Cross money because somebody has to do the work. And you have to question whether or not it's important for them to take something and make a Xerox copy of it and then file a paper copy away. That's non-value adding work because the customer doesn't care. All the customer cares for is that they get the check. So what we're talking about here is when somebody is doing a whole bunch of extra work to deliver a product that really doesn't add any value to the product that's being delivered. And that's the thing that we're trying to target with Lean, as identifying those non-value adding activities and eliminating them. It's just like, to use a simple, kitchen analogy again, if you're loading up the dishwasher, okay, and you're loading and unloading the dishwasher. So if you take all of your silverware and stuff, and you just kind of put it in the silverware tray, and then you run the dishwasher, and then you take the silverware out, and then you lay it on the countertop. And then from there, you then go through and sort it, and then you put it in the drawer. You've actually done some non-value adding work. You could have actually sorted the silverware before you put it in the trays, so that when the dishwasher is finished, you just take out the forks and put it in the fork compartment. Take out the spoons, you put it in the spoon compartment, instead of having to do the extra work of sorting and resorting the silverware. So it's just a simplified example of extra work that we do that doesn't actually provide extra benefit to the product.
We have another question, Perry.
Okay.
I'll wait till you get done.
Take one more and then we'll move on to Six Sigma.
So do these non-value added activities still manipulate the cost of products?
Yes, because they are included in the cost of manufacturing. Companies are paying somebody to do this work, or they are paying for stuff. Like, for instance, moving materials from one warehouse to another warehouse is a non-value adding activity. So they're paying for the extra storage. They're paying to relocate the product. Shipping is a value adding activity. To actually ship it to the customer and get it there is one thing, but to move it around internally is a non-value adding activity, but it costs the company money. And yes, the company passes that cost on to the consumer.
The customer. Yeah, and sometimes you do want to pay for things like quality, and something that we say in the process world is you're going to either pay for quality up front or you're going to pay for it later. So there are some things that are necessary but non-value added, meaning that they're not growing the product and getting it or the service, they're not making it better. They're not actually making it to its end form for the customer, but it's necessary to pay for them. So that's why it's called non-value added, but it's necessary.
Right. All right. Let's move on to Six Sigma. So we'll give a brief introduction to Six Sigma, and then we'll talk about what's kind of the difference between Six Sigma and Lean. So we said that Lean is the reduction and elimination of waste, and Six Sigma is the reduction of variation. You see a guy here, Edwards Deming. Deming was one of the kind of the statistical gurus from back around the time of the end of World War II, who tried to convey a message to American manufacturers that it was important to do things consistently and reduce variation in their products or in their processes. And American manufacturers were not interested in listening to him. You know, these were like the companies like Ford and, you know, car manufacturers and others. However, Deming and another guy, Duran, they took their message to Japan, who had just had their economy decimated during World War II. And the Japanese people were more than willing to listen because they needed all the help that they can get to improve and rebuild their manufacturing capacities. And they started adding a level of consistency to their manufacturing processes. And for anybody who was around buying things in the 70s and 80s, the people began to associate quality or consistency with Japanese manufactured products like stereo equipment and electronics, and cars from Japan were considered to be more reliable than cars made in the United States. And it was all about this drive towards reduction of variation, which is the essence of Six Sigma. So when you hear Six Sigma, you know, many people say, you know, so what is a Sigma and why do I need six of them? Well, the term Sigma is a statistical concept that represents the amount of variation in a process. Hopefully, you've all have heard of standard deviation, which is a measure of variation. And the symbol for standard deviation is the Greek symbol sigma. So here you see a histogram that shows for a company that makes conveyor belts, and they're making conveyor belts to a certain specification. They're supposed to be 38 inches wide. Well, the conveyor belts don't all come out to be exactly 38 inches wide. There's a range of widths, and the wider that range, it reflects the larger degree of variation. So we talk about when something is very accurate, like 95% or 99% accurate. Usually we're saying that's pretty good. As a matter of fact, 99% accurate is very good. There are some places where 99% is not good enough. Like for instance, if the postal system is 99% accurate, it means there's going to be 180,000 pieces of mail lost per hour. If doctors were 99% accurate, there would be 5,000 incorrect surgical operations per week. If pilots were 99% accurate, there would be 2 short or long landings on most of the great airports every day. For all of us travelers, we wouldn't want to take the chance of being on one of those flights that's in that 1% that's not accurate. 99% accurate means that there's 200,000 prescriptions of the wrong drugs issued every year. And for all of us millennial, or for all of you millennials, 99% accurate means you have no Wi-Fi for 7 hours per month. So the name Six Sigma comes from a definition of the amount of variation in a process. So if you have what's called a 3 sigma process, it means you have 93.3% yield, or about 6 or 7% defects. If you have a 4 sigma process, you are 99.4% accurate. And if you have a 6 sigma process, it means you have 99.99966% yield. The term came from Motorola, which was the first company to implement and develop Six Sigma. And their goal was, in their production, to have less than 3.4 defects per million parts. And that is a Six Sigma level of defect-free production. So you can see that there are many applications, particularly where there's health and safety involved, where you need processes that are better than Six Sigma. In a lot of manufacturing processes, you don't need to be quite that good. For instance, if you are a 2 Sigma process, it means you have a 30% defect rate. A 3 Sigma process is about a 7% defect rate. 4 Sigma process is a little over 0.5%. 5 Sigma is 0.02%, and a 6 Sigma process is 0.0003% defect rate. So the question is, where would you say most manufacturing processes are between what Sigma levels?
4 and 5.
So you're saying that most manufacturing processes are between a little over 0.5% waste to 0.02% waste.
3 and 4.
3 and 4.
The reality is most companies are between 3 and 4. In a lot of applications, it would cost too much money to get your defect level down below 0.5%. But in some applications, like particularly like if you're dealing with like electronics and health applications, you need to be better than that. But if you think about the stuff that we buy in stores, most manufacturing processes, they're running around, they're trying to get higher than 3 Sigma, and their target is to get close to 4. So we'll continue kind of the illustration of this concept of variation and how it relates to the distribution of stuff that we make. So we'll go back to the conveyor belt example. So a customer specifies, I want this to be a certain width, but I'm willing to take it at that width plus or minus 1 inch. So there's a lower specification limit and an upper specification limit. And everything outside of those limits is going to be defective. So those things, of course, cost the business a lot of money because they can't sell those. So what you're seeing in this picture is a distribution that has a Six Sigma level of about 1. It's about 1 Sigma. If you tighten up the process and are able to make the products that where most everything fits between the upper and lower spec, you now have a 3 Sigma process. And if you're really good and are able to keep everything within specification, it's a 6 Sigma process. So 6 Sigma, it's a rigorous structured process for continuous improvement, and it can be used to improve any business process. So we talk about it a lot in the context of manufacturing, but as I mentioned earlier, it can be used in transactions. Basically anywhere you have an output that can be measured, there's an application there's an opportunity to apply Six Sigma to make that process better. I've even explained to human resource people who think that Six Sigma doesn't apply to like personnel issues. And I say it absolutely does, because if you're evaluating performance of your workers, or you have people issues, the performance of your workers should be based on some measurement of performance. And therefore, if it can be measured, it can be improved by using a process like Six Sigma. And Six Sigma focuses on 2 objectives for your process. 1 is centering the process around the target, and 2, reducing process variation. So what does that look like? So here we have our target, which is the bullseye. And here we have an example of where we are shooting at, and we're consistent in our where we're hitting the target, but we are off center. In this example, if we kind of average the locations, it averages out to where we're on target, but you see we have a lot of variation. So what Six Sigma is trying to get us to do is to, one, center the process and to reduce the variation so that the majority of what we make is centered around the target. So the Six Sigma methodology identifies that processes are off target and or have a high degree of variation, and it corrects these processes. So throughout the training, we're going to be constantly referring to our efforts to get the process on target and to reduce the variation in the process so that we have a process that consistently meets the goals and objectives.
And Perry, can I chime in on that last slide real quick? For a lot of the transactional people that I've worked with internally, sometimes in a transactional environment, before they can even center it, they need a stable process, a consistent process. People may do something different, multiple, different ways. But once you get something that you can get consistent, whether it's right or wrong, you can get consistent with it so that it can be studied. Then you can understand how to center it and how to reduce the variation and drive the outcome that you want. So reducing the variation, even in how you're going about it. So actually being more consistent in what you're doing so it can be measured and studied.
Yep.
And that's easy. That's easy to do in manufacturing environment because you have some things that drive it to have to be done a certain way. But in transactional environments, it's not as easy to see.
Well, it's not as easy to see because we're not used to looking for it. But one
Right.
of the things that we'll learn in Six Sigma is, regardless of the process, we'll learn how to look for the sources of variation. This is just kind of a graphical representation. We have a process that is fairly consistent, but it's off target. So we're making a lot of stuff that's going to be out of spec, in contrast to another process that may be on target, but it has a lot of variation. And like I said, we want to shift this and center the process around the target and squeeze and reduce the process variation. So I want to quickly summarize Lean and Six Sigma, because I'll ask a question. So we've talked about Lean as a reduction and elimination of waste, and we've talked about Six Sigma as a means to reduce variation. So one question is, which is better, Lean or Six Sigma?
You have to implement them both together if you really want to get to the point, because I don't really see how you can eliminate, or let's say cut the fat without reducing process to get it centered and aligned properly. It's not going to work with just one or the other.
Okay, that's good. So the answers to these questions is always going to be, it depends.
It depends on what the question is. It depends on what the objective is.
It depends on the problem. So think of Lean and Six Sigma as tools in a toolkit, in a toolbox. Okay, so in a toolbox you have screwdrivers and hammers and pliers and wrenches and things like that. So the question is, what's a better tool, a screwdriver or a wrench? And it depends on what it is that you're trying to do. So Lean, it improves efficiency by eliminating waste. And if you think about, one of the main things Lean does is it reduces cycle time. It enables you to get work done quicker by eliminating a bunch of unnecessary steps and a lot of unnecessary rework. Six Sigma is focused on, let's go back here. Six Sigma is focused on reducing variation, so making the product more consistent. Now, by themselves, they don't necessarily provide the best results, because with lean, you are eliminating additional steps. However, an individual process step may still have and introduce a lot of variation. So you can still have defects because of variation, but you've made the process more efficient and it moves faster. Six Sigma, you may still have inefficiency, because if you do the same inefficient stuff the same way each time, you will get a consistent product. So the positive thing is, if you do the same thing every time, you will get reduced variation and you will get consistency, but it may not be the most efficient process. So, like the gentleman said earlier, by applying them together, you can optimize the process, because lean gives you better flow, Six Sigma gives you less variation and subsequently fewer defects. So, quick question, or are there any questions about what's the difference between lean and Six Sigma before we get more into the details of what Six Sigma is actually about?
We did have a question in the chat. It says, are we driving for precision? Does Six Sigma also use the terms accuracy and precision?
Yes, and we'll talk about that a lot on Wednesday when we talk about measuring.
All right, and I think people are getting it. Go ahead.
Accurate. When we go, if we go back to the bullseye, the pictures of the bullseye, the accuracy piece is being centered around the target.
Mm-hmm.
Precision is around, it's the picture of this is precision here is that target on the left, where we're hitting things consistently but we're off target. Mm-hmm. Accuracy means we're centered around the target but we have a lot of variation. So we'll work on both precision and accuracy, and like I said, those will be the themes throughout the Six Sigma training, how we work on both of those things to ultimately reduce variation.
And we have a question from Nicholas and a comment from, it looks like World says, is automation a lean process? I think it depends.
Yeah, well, one of the things about automation is it is a lean process, because one of the things that automation does is it takes out the human element of variation.
Mm-hmm. Right. But automation is not always better than human intelligence. I know some automation processes that have defect. They don't produce the desired outcome.
There's a whole nother thing about the human element versus, but
right.
But the short answer, one of the main reasons for automation is to
reduce the variation.
Is to reduce the variation that comes along with the human element, and it also enables you to work pretty much nonstop, because people need breaks and things like that.
Yeah. All right, Nicholas had a question.
Oh yes, I had put it in the chat as well. But I was asking, can you give examples of the different tools that are used in Lean versus Six Sigma projects?
So, in Lean, there's a whole big body of work in Lean. One of the basic tools in Lean is, and Toni alluded to it earlier, is something called 5S, and 5S is basically a way of organizing stuff so that everything's always in the same place, where it's supposed to be. Like, for instance, you arrange the layout of your kitchen so that everything is close to the point where you have to use it. Like I was saying, you put the spatulas and spoons, the stirring spoons and stuff next to the the stove. Your silverware and stuff is in the drawer near the dishwasher, you know. So you lay out your kitchen so that you don't have to look for stuff and you don't have to move around a whole lot. That's a fundamental lean tool. Another lean tool will be where you actually calculate the precise cycle time that it takes to complete all the steps in a process. And then you look to see where's the bottleneck in the process, which step is the slowest step. So, you know, like I said, there's dozens of lean tools which enable you to make a process less wasteful. And for those people who want to, like, this course is focused on Six Sigma Yellow Belt. There are similar certification courses for lean, which is like, we'll talk about Six Sigma as a yellow belt, green belt, black belt. In lean, you have bronze certification, gold certification, silver certification, those kinds of things, where you become very proficient in lean tools.
All right, one other quick thing, Perry. Some people are asking about the white belt, and I also did drop a link about 5S in the chat. I'm dropping some links in the chat as you're speaking. Is it necessary to go back and get a white belt if you don't have one? That was a question that came up.
No, I think I tell people white belt is just an introduction to the kind of a brief overview of Six Sigma, just to get you to buy in that Six Sigma might be a good thing. Yeah. Your first functioning capability for Six Sigma comes out of the training that we're getting right now. After today, you'll actually be able to do a couple of things with respect to Six Sigma as a yellow belt. And I'll explain it. I'll go through the roles here, and it'll kind of help you see what the significance is of the certifications. White belts, I kind of avoid it because a lot of people may go through some kind of a white belt training course, and usually it's oversold in terms of the value that you actually get from it. Yep. You really need to be at least a yellow belt to say you can actually function with the Six Sigma methodology. So a yellow belt is a core team member of a Six Sigma team. You're usually a subject matter expert, and you can lead small scale improvement projects using lean tools or best practices. You keep your current role, and I'll talk more about the staying in your role piece. You will have a basic understanding of Six Sigma tools, concepts, and statistics. Now, when the way I like to describe learning about Six Sigma is kind of like learning a foreign language. You know, when you first start to learn a foreign language, you learn to translate some words from one language to another. And over time, as you become more proficient and knowledgeable about Six Sigma, it's just like becoming more fluent in that language. So as a yellow belt, you are able to be conversational in the world of Six Sigma because you kind of understand the concepts. You can kind of talk about it. The other thing that you are able to do as a yellow belt is you will be able to identify processes that need improvement, and you will be able to define Six Sigma projects, which we're going to go into the define phase here shortly. You can also then support green belts and black belts in working on projects by helping to develop process maps, capturing data, and making improvements. The green belt is the first place where you actually really apply Six Sigma. And in order to be certified as a green belt, you actually have to demonstrate the utilization of Six Sigma tools to complete a project. So green belt, you keep your day job. You are able to lead medium complexity projects. You can be a team member of more complex Six Sigma projects. You implement Lean Six Sigma in your area of work, and you start to help build the culture of continuous improvement in Lean Six Sigma. The first place where you make a bunch of money from Six Sigma is as a black belt. As a black belt, you are now a essentially a subject matter expert in the methodology, and you can lead complex projects. You can implement the tools in different departments. You know, as a green belt, you are able to apply Six Sigma tools to the place where you work and the type of work that you're doing. What enabled me to be able to move from making Lycra for DuPont as spandex to being able to work and helping out pharmaceutical clients was because I had black belt expertise, which enables me to apply Six Sigma tools to pretty much any kind of a process. As a black belt, you can coach the yellow belts and green belts, and you're also able to now help the business with its strategy of how to actually drive process improvements. And then as a master black belt, which is what I currently am, you have an extensive knowledge of the statistical tools and the methodologies of Six Sigma. You are able to help provide leadership and strategic input for the business on how to and where to deploy projects. You are able to train and coach the yellow belts, green belts, and black belts. You have advanced knowledge of the tools, and the master black belts are the ones that usually help to direct the work. You help to identify, charter, and prioritize the projects that the black belts end up working on, and it's usually the green belts that help the black belts with the projects. So there's different levels of certification in Six Sigma. We are now offering Six Sigma certification here within NSBE and the Process Improvement SIG. And to compare how the certification process works, in the classical Six Sigma training, yellow belt training consists of 2 days, and there's no project criteria for certification. Green belt training, if you did standalone green belt training, it's usually 10 days of training, and you have to complete a project demonstrating use of the DMAIC tools. A black belt is 4 weeks of training, usually 4 weeks, 4 weeks spread out by a month each. So it usually takes about 4 months to get through black belt training, and you have to complete at least 2 projects with significant savings, typically like more than $250,000 worth of validated savings to get certification. The way we're applying Six Sigma certification within NSBE is everyone needs to start out as a yellow belt. So you have 1 full day, 8 to 10 hours of training, including the full defined module, and then you have to pass the certification exam, which is what you guys are going to be doing. To go on to green belt training, you have your yellow belt certification, and then you get an additional 8 days of training where you get more in-depth knowledge of the measure through control phases, and you have to complete a project and pass a certification exam. To get a Six Sigma black belt certification through NSBE, you have to already be a certified green belt, and then you get an additional 10 days of training with the advanced statistics, and you have to have then completed 2 projects demonstrating advanced tool knowledge, and you pass your black belt certification exam. So this just kind of shows you the roadmap of what it takes to get certification in Six Sigma. Quick questions before we kind of launch into the DMAIC process.
Perry, I'm just gonna make a quick comment on that last slide. That happens over time. Like that probably took me about 3-4 years to get green to black. That was with me working full time as a black belt, and eventually I became a master black belt. But having time to use the tools is the best way to learn them. And
Right.
every project does not give you the opportunity to use every tool. So, and you need a coach to make sure you're using the tools properly. I did see a quick question from your Akiza.
Yeah, I just would like to ask, how often do you have these classes for green belt and black belt as well?
We have been offering the Process Improvement SIG has offered the yellow belt training. This is like, I think, our 7th or 8th time offering it in the past 5 or 6 years. So we always offer it at national convention, and the intent is to offer yellow belt certification training on a quarterly basis. This year is the first year that we actually are offering green belt certification. So there's a class of people currently going through green belt certification training as we speak. The vision is that once we get some traction with the green belt certification, within a year or so, we can be in a position to offer black belt certification training. There's a significant cost associated with that. So part of it is for us as for NSBE to get the corporate support and funding to help cover the costs and things like that. But right now, like I said, we look to offer yellow belt certification on a quarterly basis, green belt classes on an annual basis at least, and hopefully within about a year or so, we'll be able to offer black belt certification training.
All right, one last question, and then we have to go forward. The recertification process, is there anything that would have to be done for green belts to maintain the certification?
With Six Sigma, there really isn't. It's not like like professional engineering certifications and things like that, where on some frequency you have to get recertified. Once you're certified in Six Sigma, you carry that certification with you. It just comes down to, obviously, if you don't use the tools, then it kind of leaves you a bit. And it really comes down to where the rubber meets the road. Are you able to execute and lead a project applying the Six Sigma tools? The nice thing is there's always reference material available, and once you're in a network of Six Sigma people like myself and Toni, you can always come back to master black belts and other black belts to help you or help remind you how to apply tools and statistics to the problems that you're trying to solve.
And I will say that with some certifying bodies, like depending on who certify you, that agency might require or say that you have to have some research hours or something like that. All right, I think I did see a question. I'll try to answer it in the chat so we can keep moving. We only have about 45 minutes left, so I'll answer them in the chat, Perry, so you can keep moving forward.
All right, let's introduce the Six Sigma process. Is using the acronym DMAIC, and DMAIC stands for Define, Measure, Analyze, Improve, and Control. Those are the 5 phases of the Six Sigma process. We start out with define, and that is, what is the real need of your customer? And we'll use a couple of symbols here. We define the need in a measurable term, and we'll call that metric as a Y. So in measure, we determine how good are we doing right now. So what is the performance of this measure Y? Okay. In the analyze phase, we look to see what are the inputs that influence the outputs. In other words, the inputs, we can consider those as X's. So what is the function of X's that gives you the specified output Y? In the improve phase, we say, okay, this is the relationship between the X's and the output Y. How can we do it better so that we get a consistent result in our output? And then in the control phase, it's how can we sustain the improvement? So what's the need of the customer? How good are we doing right now with respect to that need? What are the inputs that influence the output? How can we do it better? And then once we've made the improvement, how can we make sure that we sustain the gain? So quick question. Of the 5 phases, which is the most important of the 5? Any thoughts?
I would say improve.
See some saying define, I hear improve.
I think
So a lot of
grow.
So a lot of people will say the politically correct answer is control, because what happens is in many cases we quote unquote improve things and then we somehow backslide because we didn't do enough to sustain the improvements. But I will say that the most critical phase is the define phase, because if you don't accurately define the problem, then there's no guarantee that you are working on the right thing. And there's no assurance that you're going to get to what's the root cause of what's actually driving your variation. And so the define phase is where I typically spend the most amount of time in teaching Six Sigma up front, because the measure piece, and I'll just take a step aside to say that the thing that differentiates Six Sigma from many other problem-solving methodologies is the measure piece. Because in Six Sigma, it's all about using data and making data-driven decisions, using statistics and statistical analysis to draw conclusions. I like to say that, thank you for sharing your opinion, but show me the data. So in Six Sigma, if you're not speaking from a data standpoint, then you're not really speaking in a way that that people really need to listen. Like I said, opinions don't matter. It's about what's the data telling us, and it's a very rigorous methodology that aims at getting the data, analyzing the data, and drawing statistically based conclusions. The define piece is so critical because we have to first understand what is it that we need to be measuring, because in a lot of cases, we articulate a problem with a problem statement, but we don't have a way of measuring it. Then the classic example is we have poor communication. Okay, most people may agree or that we have poor communication, but how do we know that if we're working on improving communication for 3 or 4 months, that we have actually made a difference? So you have to find a way to measure communication such a way that after working on it to improve it, you can confirm whether or not you've actually made a difference. So the define piece is critical. So let's talk about the define piece. And we'll use a couple of terms here. One is CTQ, and that stands for critical to quality characteristics. And this is a key measurable or characteristic of a product or process. It implies the performance standards that must be met in order to satisfy the customer. Remember, at the end of the day, we are meeting customer needs. So critical to quality is what the customer is telling us is important to them. And if you think about when you as a customer, what is important to you when you are buying a product? One is the quality of the product. The stuff has to do what I want it to do. Another thing that's critical to quality for a customer is the delivery of the product. There's got to be, if you order something, if it arrives late, then it's not meeting your quality standards. And usually another critical to quality item for the customer is a price point, right? So these are all things, these are all CTQs, are what's critical to quality for the customer. And these are the things that your project or your process has to work on. Now, the way you work on this, and we call this methodology a CTQ flowdown. You start by what's the voice of the customer, and the customer tells you what's critical to quality. You have to then turn that CTQ into a measurable that comes out of your process. So this is, we'll call that the project Y. So that's the process output that directly relates to the CTQ. And specifications for this output determine defects. We then need to identify what are the process inputs that impact the project Y, And once we come up with this comprehensive list of all the inputs, we need to figure out what are the 3 or 4 or 5 most critical inputs that we really need to be controlling to get the desired result. Now, I'll quickly define what's the difference between a CTQ and a Y. And here's a simple example. So as a customer, you are looking to pay no more than a certain amount for something. So you're looking for a certain price, right? In your manufacturing operation, you don't control price, but what you do control is cost. You control how much it costs you to make it. So the customer is looking for a certain price, that's their CTQ. You know what profits you need to make and that kind of a thing, but the thing that you can control in your process is the cost. Customer wants, their CTQ is, I want it delivered within a day. Used to be, they want it delivered within a week, but now everybody wants it within a day. The thing that you work on in your process is cycle time. So your Y is cycle time, which is the time that it takes from when you start making the stuff to the time that you actually are able to deliver it. So our focus will turn to looking at Ys, which are outputs, and ultimately we need to understand the inputs that impact the outputs. So in the define phase, we focus on understanding the customer needs and turning that into something measurable. Now, the way we get the customer needs is we need to understand the voice of the customer. And really for a customer, I like for us to think about there's 4 voices. There's one is the voice of the customer. So this is where the external customer, they want quality that's good or better than the competition. Or it could be an internal customer, because if you're manufacturing something and you're putting in step A and then you're passing it on to the next step in the manufacturing process, which is step B, you now have an internal customer that also wants stuff to be defect free. But another critical voice is the voice of the business. The business must meet the customer demand, and the business is looking for us to reduce waste or reduce cost. For you as a project leader, particularly if you're working in a manufacturing environment, it is very important to take into account the voice of the employee. What us engineers what young engineers have a habit of doing is we go out there and we come up with a solution to a problem that involves making some changes to a manufacturing process. And then we expect the operators who've been working this process for 15 or 20 years to quickly adapt it and make the changes. If you have not gotten input from the people who are making the process or who are running the process today, as you went about figuring out your solution, then you may not get the buy-in that you need from the employees to make that change. Or they may be okay with the change, but they don't want to do extra work. So it's important to get an understanding of what the employees' input is into the process. The 4th voice is the voice of the process, and this is the data and the measurements that come from the process. And the voice of the process can be measured in terms of a primary metric, a consequential metric, and a secondary metric. And I'll define the different types of metrics here shortly. So one of the first deliverables in the define phase is to come up with a table that looks kind of like what you're seeing here. You're capturing the 4 voices where you articulate what's important to the internal and external customers, what's critical to the business, why are you having to work on this project, what concerns do the employees have about this project and what's important to them, and what is the current process performance as measured by the primary, secondary, and consequential metrics. So this is the first deliverable in the define phase. So once you've captured the voice of the customer, then you need to focus on a project charter. Now, projects often begin as a vague concept without a lot of structure or definition, and a project charter is a tool in the define phase to develop the structure and definition that is required to successfully execute the project. Now, I'll ask a question here, and you can put some things quickly in the chat. If you're on a project team, or if you're working on a project, and some of you may have experience in working on projects, why is it that projects fail? Or why do project teams fail? What are some of the reasons as to why projects fail, or why project teams fail to accomplish what they're trying to do? So just take a couple of minutes to put into the chat, what are some of the reasons why project teams fail? So scope's not defined, participation, misaligned priorities, lack of effective leader, poor process implementation, poor communication, lack of expectations, no teamwork, misunderstanding of project goal, lack of understanding. Team doesn't have the same vision, poor execution, goals were not achievable, no structure, different work styles, undefined deliverables. Good. You've captured a lot of the key elements as to why projects fail. These are some of the key reasons. The team is not supported by management. The project scope is too wide. Project objectives are not significant. A key one is a clear measure of success is not formulated. Team members have multiple agendas, and I like to quantify this one as both agendas with a small a and a capital A. What I mean by team members may have different agendas. They may have different personal agendas in terms of personal objectives or different stakes in this project, or they may have different schedules. It's tough to align people's schedules so that they can work together on a project. The project is not aligned with priorities of the business. Here's an interesting one. The team is too large, and I'll say that the ideal size of a project team is 3 to 6 people. Now, let me further explain this. In many cases, project teams involve a lot more than 3 to 6 people, or they may be, there may be 20, 50, 100 people working on a project. When I talk about the project team being too large, if it's more than 3 to 6 people, it's those people that are essentially running the project and making the strategic decisions about the project. That group needs to be manageable in size in terms of 3 or 4 or 5 people. You may bring in dozens of other people to do certain work within the project, but they are not the decision makers about how the project is going to be run. Another shortfall of project teams is that the team is not adequately trained, and what's very relevant to Six Sigma projects is data are not readily available. If you can't measure what you're doing, then the project is not going to be successful. So for a team to be successful, you need to have management support and sponsorship. Toni mentioned that it takes time to get your Six Sigma certification because it takes time to do a Six Sigma project. You can do a lean project within a matter of days, sometimes even hours. Six Sigma projects takes weeks and months because you have to actually collect and analyze data, get a lot of historical data, and sometimes develop new data in order to do the necessary analysis to figure out what factors are actually impacting your output. Having a manageable project scope, having the project goal be significant and consistent with business priorities, having a clear measure of results. You need a good process owner, and you need to follow the DMAIC methodology. having a project charter makes sure that your team has a business case that's aligned with the organization's strategic objectives. It makes sure that the project scope has been defined, that the targets are clarified, that the roles and responsibilities are clear, and that the team has an elevator speech defined and ready to communicate to others to help them understand why are you doing this project. And it helps the team members to know, why is it that I'm here? The process owner is not necessarily a team member, but it's a critical resource. It's typically the single individual serving as the contact for the black belt or the green belt project team. They understand the business needs and they are empowered to make decisions about the process. And they are the ones that become the owner of the project results and the ongoing implementation. If you think about it, if you're an engineer in a manufacturing process and you've been assigned to work on reducing the waste that comes from a production line, the process owner is the supervisor of the area that is responsible for that production line. So you are going to help fix the problem and make that process run better. You're going to basically provide a recipe of this was what needs to happen in order to reduce the waste. And that recipe then goes to the person who's actually responsible for running that production line to implement the changes and to then own the results. You need management support. They are accountable for the business results. They need to make sure that your project is aligned with business objectives. They help prioritize the work, and they remove barriers. If you need money or resources or things, they help get those. Or the managers, of course, have veto power over the project. They may decide that it's not as important to the business as having you to work on something else. So you need to have management support for your project. So why is a project charter needed? So I'll go through a simple parable from invoicing. So the VP of sales comes into the quarterly employee meeting and says, the customer is unhappy with our invoicing. Let's get out there and fix it. So now everybody hears this dynamic message from the VP and everyone's ready to go solve this problem. So they say, okay, the customer's unhappy with our invoicing. We need to go fix it. And each of 5 employees says, I know what the problem is. And they marched off to take what they thought was the appropriate corrective actions. So according to the accountant, they define the problem as the customer would like to do his closing sooner and we send our invoices too late. The IT system manager said the customer would like more time to pay and we need to send the invoice too early. One clerk says the customer is irritated by every mistake on the invoice. But another clerk says that the customer considers the invoice either right or wrong and is only interested in the bottom line. And whenever the salesperson hears that a customer is unhappy about anything, they assume that the customer would like the lower prices. So like I said, everybody heard that the customer is unhappy with our invoicing. Let's get out there and fix it. Each of 5 people ran out, believing that they knew what the problem was, and they set out on a course of action to fix the problem. So what they did is the accountant went to accounts receivable and he immediately issued a new procedure which issued invoices 5 days earlier than normal. The IT person went back to the computer and changed the code to prevent invoices from being generated any earlier than 45 days from shipment, now 15 days later than normal. One accounts clerk, he meticulously checked every field of information on every invoice 3 times, correcting errors through rework, which delayed processing by several days. Another clerk began checking for errors, but only checked the invoice total for mathematical accuracy. And of course, the salesperson for the account went back to the customer and lowered all the prices. So the moral of the story here is you have to be clear on what the problem is, define the problem in measurable terms, and make sure you're working on the right problem, or else you're subject to work on a number of different solutions, none of which may actually be a solution to the problem that actually exists. So the project charter is a document to help direct the strategy from the business team, the connect the process owner, and the Six Sigma champion or master black belt to the improvement team, the team leader and its team members. This is just an example of a project charter template, and it will include basic information like, what's the process, who's the process owner, who's working on it, who are the core team members. I'll draw your attention to the key elements of the project charter, which are very critical. One is, what's the business case or problem statement? And this is a statement as to why is this important to the business? It's the what, the where, the when, to what extent, and I know it's a problem because statement. There needs to be an objective statement to improve the process from A to B by when. There needs to be metrics defined for the problem, and I'll explain what's the difference between the primary, the consequential, and the secondary metrics. And you have to define the scope. What's in scope for the project and what's out of scope for the project. So if we look at the problem statement, and this is where everything starts, a problem statement needs to have the form, what is wrong, where it happened, when it occurred, to what extent, and I know it's a problem because. Now, here's what a problem statement does not include. It does not include causes of deficiency or place blame. It doesn't say that the problem we have is due to operator error. The problem statement needs to say we have over 8% waste on this line for the past 10 months. The problem statement also does not include actions or solutions. It doesn't say we need to implement this new control system. It says that the problem is we have this defect level over this period of time as measured by such and such. The statement needs to be clear, concise, and specific. It needs to be quantitative and measurable. So a good problem statement will define what is wrong. Like, for instance, customers are not satisfied with wrinkled paper or delivery time is too long. It will clearly say where the problem occurs. So customers are not satisfied with wrinkled paper made on machine number 1, or delivery time is too long for customers on the East Coast. It explains when the problem occurred. So the customers are not satisfied with wrinkled paper made on machine 1 since installation of the new drives in August, or delivery time is too long for customers on the East Coast since startup of the new warehouse deliveries have been slowed. And it gives the extent of the problem. That wrinkles now account for 11% of defects, or delivery time is too long since startup of the new warehouse deliveries. It's been slowed by an average of 2 days. So you see what the problem is, where it occurred, when it occurred, and a quantification of the problem. And how do I know it's a problem? Well, prior to the installation of the new drives, our historical average for defects was 4%. It's now 11%. How do I know that delivery time is too long for customers on the East Coast? Because customers are now filing more complaints. So how do I know it's a problem? Let's go through a quick exercise here. So in each case, I'm gonna list a problem statement, and we need to identify what's the what, the where, the when, the where or when, the magnitude, and how do we know it's a problem? So if we have a statement, yields and ore recovery are below last quarter as measured by 2% increased loss to the landfill. So what would we say, what's the what here? Somebody put in the chat, what is the what? What is the problem here? The problem is yields and ore recovery, right? Where and when? So it's below, yields in ore recovery are below last quarter. What's the magnitude of the problem? %. And how do we know it's a problem? Because there's more stuff in the landfill. Okay. Let's look at another example. 73% of our product shipments arrive late at all of our customers' operations. So what's the what? What is the problem? Product shipments arriving late. Where and when? I always question when they say that it arrives late at all of our customers. I'm not thoroughly convinced that that's true. I would need to see data to confirm that. What's the magnitude of the problem? %. How do we know it's a problem? It doesn't say how we know. Here's a classic problem statement. Callers are highly dissatisfied with the helpline service. So what's the problem? What's the what? So they say callers are dissatisfied. What's the where and the when? We don't know which callers. What's the magnitude of the problem? We really have no idea. Well, what's the number associated with highly, you know? And how do we know it's a problem? Because that's what Joe said. Joe said the customers are highly dissatisfied. So another example, online surveys indicate that users of our corporate website cannot find the information they are seeking. So what's the what? So users not being able to find information. Where and when? We don't really know from any time horizon. How long has this problem been going on? We don't have any idea. There's nothing here giving us the magnitude. Now, how do we know it's a problem? Because we do have surveys. So what we're seeing in example 1, we basically cover all the key elements in the problem statement. In examples 2, 3, and 4, we were missing key elements. But it's important, and this is why I emphasize how the importance of the define phase in the DMAIC process. If you, as a project leader, you will receive problem statements from people or problems and things that you need to work on or that they want you to work on. It is important that you get them, the people who are giving you these problems, to be able to articulate what the problem is, where and when this problem occurs, how long has it been going on, what's the magnitude of the problem, and how do they know it's a problem? Even if they say that the problem is poor communication, what do you mean by that? Well, it's like when a message comes down from corporate headquarters, I'm always 2 weeks late receiving the information, or it's only getting to 50% of my people, or it's missing certain pieces of information. So now when you say, okay, I'm only getting 50% of the information, or I'm getting the information 2 days after I need it, now you're starting to put some quantification to it, which means that now I can think of something that I need to work on that's measurable. So the key thing about problem statements is to put it in measurable terms and to spell out specifically what the problem is. Once you do that, then you can come up with an objective statement for fixing the problem. And hopefully many of you have heard of the acronym SMART for setting goals. Okay. So now we get background music for the class. So somebody needs to go on mute. Okay.
Yes.
So objective statements should be specific, measurable, aggressive yet achievable, relevant, and time-bound. So when you write a goal statement, it needs to include these elements. Example of a goal statement: reduce folds and pipes off of blow mold machine number 1 from 11% of total defects to 4% by September 31st, 2023. So it's a specific goal around a defect that's measurable, it's achievable, it's relevant to the process, and it's got a time element to it. Let's quickly talk about metrics, since at the end of the day, what we need to get to is how to measure the things that we're working on. And I mentioned that there are 3 types of metrics: primary metric, secondary metrics, and consequential metrics. The primary metric is the main thing that we're working on. This is the specific defect that we are trying to fix. It's the gauge used to measure your process, and it must be consistent with the problem statement. This is what you're going to use to track the progress towards your goals and objectives. So your problem statement is driven around the primary metric. Example, you can have breaks per day or tons per day or width variation in conveyor belt. It can be some specific dimension of the product you're trying to manufacture. It can be the specific measure of the defect. So that is your primary metric. Now there should only be one primary metric for a project. Why would that be? Why should we only have one primary metric for a Six Sigma project?
So that we can target that one?
You need a singular target.
Yes, it is critical to be able to focus the project on a singular measure, particularly because it is very important to manage the scope of the project. You're ultimately going to assess what are the different inputs that impact that one metric. And if you try to solve too many problems at one time, it becomes too complex and you won't be able to sort out what is impacting the main thing that you're trying to fix. Now, if you are dealing with, say, for instance, reducing waste in a process, and there may be several different piles of waste or several different sources of waste. The way to deal with that is you split up the project into multiple projects, each project dealing with a certain pile of waste. Now, the way you carry out the project, it may be like a cookie cutter type of thing. Well, I solve it for one part that's defective, and I'll do the same thing for the next part that's defective, and then I'll do the same thing for another part that's defective. But you keep the different projects separate because you want to only work on one primary metric for a project. Now, secondary metrics. These are key outputs that may improve as a result of meeting the objectives for the primary metric. Now, these may be business metrics. Like, for example, if you are working on reducing the width variation in conveyor belts, so that's your focus. I mean, we're trying to make this belt that's 40 inches wide and we're trying to, and right now we're making them in a range of 38 to 42 inches, and we're trying to narrow that variation. A secondary metric that might benefit from your work is we're currently having to trim if we're making the belt too wide, we're having to trim the edges off and throw that away. So by working on reducing the variation of the width, we are also reducing the total waste that we throw away. Or another example may be if our primary metric is reducing the tons of inventory. By reducing the amount of inventory that we have, we may actually free up floor space that can be available for something else. So the secondary metric is kind of a side benefit or an added benefit of fixing your primary problem. Now, what is a consequential metric? Does anybody have an idea of what a consequential, if we have a primary metric and a secondary metric is a side benefit that comes from working on this project, what might a consequential metric be? When we think of the term consequences, what does that usually suggest?
If you do one thing, it might cause another a different reaction or.
Right.
Something.
We oftentimes think of consequences as being something negative. So this is a consequential metric is an unintended negative consequence of process changes. You want to think about consequential metrics as your conscience to keep you honest, to keep you from passing your problem on to another area. And there's some classic examples of consequential metrics. Like for instance, if you are working on reducing inventory, good news is you reduce inventory. The bad news can be that you may run into a situation where you don't have enough product available because you had a disruption in your production process, and now you're out of inventory. A more classic example is our salespeople, or our purchasing people, I should say. They will go out and they'll find a cheaper raw material for making your product because it saves on cost. But they may end up getting a cheap product from China or someplace that just doesn't work as well in your process. And therefore it becomes a reliability issue in your manufacturing process. So that's a classic example of, you're doing good on one end, you're reducing cost, but you created a problem on the other end. So consequential metrics are not always obvious. You need to ask what can go wrong to figure out what the right consequential metric is for your project. Questions about metrics? All right, so I'm going to pause here and ask if there are any questions that we have so far about Lean, the introduction of Six Sigma, or what we've covered in the define process. There's one more key element to define, and that is the high-level process map. It'll take a good 15 minutes to go through that. We may want to just go ahead and save that since we're pushing close to 8 o'clock. We may want to start promptly with that when we get together on Wednesday. But I wanted to just take a pause here and field any questions that we have so far about the concept of Lean, Six Sigma, and what we've covered so far in defining a problem.
And also too, I want to check the roll because I do see there are a lot of people who are not here on the list that I have versus those that are signed in, and there may be some people who are signed in that are not on the list. So I want to just take a few minutes and make sure that we have everyone present that is here. We have the right addresses. So if you guys have quick questions about what was covered, please go ahead and ask those now.
I was wondering, are we going to get a copy of this presentation?
Yes, there's a. I sent. I'll send Toni a PDF file that she can distribute to you guys with the course materials.
I have a question about the data that has to be attained for some of these projects. I think in my mind, I kind of answered my question now because you're working on a team. So somebody on that team has to be a data analyst because they have to process the data and they have to get it from somewhere. And then it has to be presented in a format where everybody on the team can understand what's going on. So like, if somebody doesn't have those skills, then somebody on the team would have those skills so that everybody can work, correct?
So as a green belt, you will. So we're going to talk about data and data collection and the starting process for data analysis on Wednesday. As a green belt, you will have enough capability to be able to know what data you need to collect and to be able to go out and ask for and collect the data. And you'll also have some skills in terms of using a statistical software package to help analyze the data. So as I mentioned, the green belt is the first level where you are actually have some functioning capability in terms of being able to work a project, because you will get a basic overview of the statistics necessary to do basic data analysis for a project. As a yellow belt, you will see it. We're going to cover a bunch of stuff about basic statistics on Wednesday, so you'll be able to get some insight as to some basic analysis that needs to go into a project. So I'll be able to answer that question in a couple of days.
I had one more question from earlier. Okay. It was back when we were doing a little activity together where you were saying like the who or the what was the problem and how that was measurable. So that was very like that was quantitative analysis, but for qualitative data, like for example, my project or my program is going to use a lot of qualitative data as far as like student satisfaction or increased knowledge awareness. Is this something that you could apply to qualitative data?
Well,
I can chime in on that one if you want me to, Perry.
I mean, yeah, I mean, we've already talked about how do you measure satisfaction?
I mean, a Likert scale, for example, is one way to measure.
Exactly. I mean, survey data is key, is a key data form that's used in Six Sigma projects. And the other thing is, you know, in terms of all the qualitative type information, it's interesting because I've had people working on projects to improve training material. So, you know, how do you measure, you know, training material? You know, how do you measure that you have, you know, that forms are being filled out correctly? And if you think about it, there's like all the different fields in a form, and each one of them is, you know, there may be like 12 fields in a form, and there's, you know, 1,000 forms that come in. So you basically have 12,000 pieces of data that the fields could either be right or wrong. So one of the things that you will develop the more, and this is kind of like what I was saying earlier about how learning Six Sigma is like learning to speak a new language. After you do enough of this, you start thinking, you start hearing problems, and you immediately start thinking in terms of how do I measure it? And it is different from what we do today, because typically we just talk in terms of qualitative problems. but being able to translate the qualitative piece into quantitative measures is kind of the magic that comes with experience and knowledge in Six Sigma. I mean, I have loads of fun as a master black belt working and coaching green belts through their first projects, because they all come with very significant problems that has real challenges in terms of quantifying, quantification and data. Even in some places where the metric may seem obvious, the question is, how do I get that data, or how do I get enough data? So those are the other challenges that you run into with a Six Sigma project. But that's where the work comes in, and that's why the problems haven't been solved yet, because people haven't taken the time, or they don't have the skills in terms of getting the data that's necessary to understand the relationship between the inputs to the process and the output that you're trying to fix. But that's what you learn by studying Six Sigma. Other questions?
Yes, I had one. Well, actually, I had two, but the first one was, do you have any other reputable templates for creating a project charter?
The answer is yes. I have several. You can kind of. I'll give out several different templates at the end of the course, but the point is that there's key elements that you need that depends on how you want to apply it in your business or your operation. The information that's needed in all project charters, you need to be able to articulate a business case, and you need to have a goal statement. You need to define the scope, and you need to define the metrics. Some projects have financial stakes, or some charters you may have a way of tracking the status of the project. There's a whole, you can come up with your own template or find a template. I put the emphasis as part of the training on how do you fill in some of the key elements that any project charter needs to have. But I can give you I'll provide some other example templates that may be more relevant to you guys. Yet another question?
Oh yes, I did. So I was asking, because currently I'm in a role where it's kind of like I had to come up with a project charter, and I was asking, how would I like downscale the project scope, since it's actually my first time doing it, to like the level of a yellow belt, entry level, I guess, practitioner.
Couple of ways to do that. One is you can just get some help. Mm-hmm. I always throughout this process, and I mentioned kind of earlier that you're entering a network of Six Sigma people, and so you can always, once you know some people who are like Six Sigma black belts or master black belts like myself or Toni, whatever, you can always call one up and ask, how do I do this? The other thing is, once you realize that you're breaking this up into a measurable, and like I use the example of waste. So you may be given the charge to reduce the waste from this production line by 12%. Okay, and when you look at it, like I said, there may be several different sources of waste. So what you'll want to do is you'll want to see how can you split up and count up the different sources of waste, or the different piles of waste, and then you like do a Pareto analysis, and you say, well, I'll work on the biggest pile first and forget about the smaller piles, you know.
Okay.
So you can think in terms of, your project or your problem may involve a bunch of different things, and you just basically find a way to split it up into multiple problems or multiple pieces of a problem, and then make a decision on which one are you going to work on first.
Okay, and can I also ask some of the questions I had earlier? I think it's only like 2 or 3 more.
Is it okay if
Sure.
we go ahead and end the class? Because there may be some people who need to leave. Can you stick around for a few minutes?
Oh, yes, yeah.
Okay. I do want to make sure I have everyone. I do see some people that don't have on the roll. So I don't have your email address. I don't know how you actually got into the class, but you're welcome to stay. I want to share my screen real quick and just make sure that I have all the email addresses. If you don't see your name here, I'm kind of going through numbering to make sure I'm not missing anybody. But if you do not see your name on this list, and I don't have you present for the class. Okay, so just look at this list. If you don't see your name here, and it's not alphabetized, it's just kind of how you logged in. Some people register multiple times. This is how you register for today. So I'm just going to scroll through. If you do not see your name on this list, then I don't have you as coming. I did add a few people that I was able to grab, and I'm sure after we end the call, I'll be able to download a new one. But if you don't see your name up here, don't pay attention to column B, just look at C and D. The Y means you're here. And if you logged in with a different name, I'm not able to tell that, but this is how people register for the class. So if you don't see your name up here, please drop that in the chat, just so I would know to say add me in the name that you're going to be using and your email address. Melody, I don't have your last name. I don't have an email address for you. So anything I send out, you won't get because I don't have any record of you registered for the class. Everybody listed, I have an email address for you. There is one person whose email address is bouncing back and I don't see them in the class. So I guess I don't have any way of reaching them. So anybody have any issues with anything they see here? World, I do see you. You had another name in front of your name.
Yes. My question was just how do we know if we're registered for Wednesday and Saturday? Because I think I am.
Okay. Well, I'm gonna base off of tonight. I will use the same list for Wednesday. Some people registered and some did not. Like 10 people didn't register. So I have to go back and say, well, who didn't register? There was an email sent out. Did you get that email yesterday that said register? Were you able to register? Okay.
Yes, I did.
If you got that email yesterday that said, I don't know if you registered or not, please register through that email. Tonight is the master list. So anybody that missed tonight, they have to make that up tomorrow, and hopefully they are realizing that. But if you have not registered for day 2 or day 3, you need to do that. Each day you need to register separately. So based on tonight is the master list. If you're here tonight, you hear me telling you, check your email. Check it right now before you leave. If you don't see it, let me know before you leave, and then we'll make sure you get registered for Wednesday, and you can access Wednesday and Saturday. So you guys are making me do some lean manufacturing, not lean Six Sigma already. Throwing some curveballs at me, giving me some live examples of how we can improve the process. All right. Vanessa, did you not see your name? Or you have a question? If you're speaking, I can't hear you. Okay, Samantha, I didn't see you register for, as of Friday, I did not have you registered. And Ali Mami, I added you. Okay. So yeah, I'm seeing what's in the chat, and I will send out the meeting notices. Make sure you have the other 2. I'll send out the slides from tonight. Okay. All right. I'm seeing the ads. Thank you for allowing me to do this quickly. All right. Wesley got you. Rachel got you. Ali Mami, Samantha. That's it. Okay. And if you have any questions for me between now and Wednesday, I probably will not see the email. So here's my phone number. Just that's the best way to reach me. All right, back to you, Perry, and we can let's go ahead and close out. I know there may be some other questions, but I don't want to hold people because I know you've been here for a while. We can end the recording. And if someone missed it and they'll reach out to me via email, they can probably make it up tomorrow, but after Wednesday, we won't be able to add anybody else. So at this point, we're closing out. If you want to sit around and
I'll stay here and answer
talk
questions.
a little bit longer, just for maybe like 15
15
more minutes, we can do that.
Yep. If you guys want to continue asking questions, I'll stay here. But the rest of you, if you need to head out, you can go ahead and log out. Anybody else have questions?
Thank you so much.
All right. Thank you, Keandre, Aggie crew,
Thank you.
everybody else. Appreciate you. And look, this class is career changing. You don't hear as much about it, but what I have been doing probably for the past 15 years has been a result of me being a Six Sigma, regardless of the title. Once you get to, and again, it's all about how can you apply the tools. Now that CTQ tool that we went over, career changing. You can use that in so many different applications. Kind of like when you go play golf, you have all those clubs. You only need like 3 of them. You don't need all of them. But that CTQ tool is like, if you don't learn anything else, learn that tool and how to use it, because you can apply that so quickly and easily to help you figure out